on trying to figure out what the slope of the tangent line is to the curve y equals x squared at the point -2, 4. And just as a reminder, the tangent line is really the line that this curve looks like if you zoom way into the point. So if I zoom way into this point here, then that curve really looks like a line. And I want to capture what line does it look like. Now, I have actually graphed the tangent line here, and so we can see what our goal is. The way that we're going to do this, and this is really the way that you always calculate the slope of a tangent line, is you first start with some sort of nearby point, and then we're going to calculate the slope of a secant line, and so that's the work that we're going to do in this video. And once we get that secant line, we're going to move that nearby point closer and closer to -2 until so that we can see what the slope of the tangent line should be. Okay? So let's get to work on that. I'm actually going to move this a little bit farther away just so we can have some space to see it. Now the line that goes through 2 points, this has a slope which is the rise over run, or the difference in y values divided by the difference in x values. So I have here an m already set up, and this point is labeled with a b comma b squared. So any given x value here, I can find a point on the curve by taking coordinates which are the x-coordinate is this number here, and then the y-coordinate is the square of that number. That's the definition of this curve. Okay, so this point has coordinates b comma b squared. Okay, and so this other point has coordinates -2 comma 4, and so the slope then is going to be the b squared minus 4 all over b minus -2. Okay? So right now, if I was to draw a line through these 2 points, then the slope would be -1.25. That feels about right to me. The slope should definitely be negative. It's sloping down. Okay? And it's steep-ish. Not nearly as steep as this curve here, but steep-ish. So now that we have this m calculated, and that is a live calculation of m, it changes as we move b around. And we can actually even see as b gets closer and closer to -2, it looks like we could maybe predict what the slope is going to be of that orange line. And if I make b actually equal to -2, what happens? See if you can figure out why that happens. All right, so if b is -2, look at what this slope is. If b is actually -2, then b squared is 4. So I have 4 minus 4 in the numerator, that's 0. And -2 minus -2 in the denominator, that's 0. 0 divided by 0 is undefined. So we can't actually make b equal to -2 and calculate the slope this way. So that's kind of our motivation for, or one of our motivations for discussing limits. We're not looking for where b equals -2, this is not defined, but we're looking for what number does this get closer and closer to as b gets closer and closer to -2. That's the notion of limit. We're going to say, what is the limit of this slope as b approaches -2? So once we have that, and I'm just going to move this over here again so that we can kind of see it, we can write the equation here, and I'm going to use the value m here. If I just put in m, that puts in the equation y equals -2.68. And so, but this, I should be getting a line which passes through -2, 4. Oops. Let's say it passes through -2, 4 and has slope m. And so if you remember how to write the equation of a line given a point and a slope, we can start with the y-coordinate, and then we're going to add the slope times how far we are away from the x-coordinate. Okay, let's double check. And now, so that is going to use this live slope. So if I change where my b is, that should actually follow. Yes, we have legitimately written the equation of a secant line that passes through -2, 4 and b squared. Okay, and the closer we get b to -2, the closer that secant line comes to being a tangent line. And so we can actually check to see. I've made a table of values. You might have actually seen this when I made, when just looking at m here, you can actually see as b gets closer and closer to -2, it looks an awful lot like m is getting closer and closer to -4. And so I actually made a little table of values here. I put as this column just I just called it capital B. It can't be the same number b because that confuses the program. So I called it a capital B, and I did this as the same calculation, b squared minus 4 divided by b plus 2. That's minus a -2. And I took various values of capital B that are close to -2, so 2.1, 2.01. So getting closer and closer to -2, these are values coming in from the left of -2. And here, coming in this here to closer and closer to, if I put in -2, that's undefined. So getting closer and closer to -2 from the right, it looks an awful lot like the slope of the tangent line should probably be -4. So we could guess that maybe the slope of the tangent line is actually -4, and so we could try that. So it'd be 4 plus slope is -4 times x minus -2. And looking at that, that looks an awful lot like the actual tangent line. Let's get this out of the way. So it's a good guess that actually the slope of the tangent line is -4.